Well, let me tell you a little something about me. When it's Saturday night, I need to blow off some steam. 1, 2, 3, 4. Well, I've been holding it in since o'clock in Monday morning. From the end of the week, I'm about to blow. We're walking to the honky tonk like a pack of wolves now. Order up a round of shots and it's away we go. It's a throw down, get down. Order up another round of shots. Gonna get drunk, get some, have fun. Get into some trouble, baby, like in a night. I'm a gym, been drinking, big drink, singing la 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 la, dancing machine. Been a hell of a week and I need to blow off some steam. Look at those. Steam for blow up. I've been holding it in through the whole work week. Now it's Saturday night and I'm about to blow. So come on now, man, if you play me none of them slow songs. I need boots, scooting, barn burning, hell raising, get up and go songs. But give me something hot, just give me all you got. Now let's give old Luke Miller a try. Go ahead.
So I'm going to show my ignorance here. When I got the Acroturn lathe, I thought that what it used was a D13 mount. D meaning the locking pins and 3 meaning 3 pins, because the Monarch is a D16. Yet I ordered my buck chuck with a D13 backplate off eBay, and lo and behold, there's a difference. So this is a D14. So is that the base circle diameter of the locking pins? I don't know, but that's a D13, that's a D14. I have to make the D14 fit the buck chuck to be usable. Now this is a stock buck 6-inch 4-jaw chuck with a dedicated backplate. Came together as a set. This is a no name, I don't know what it is, 3-jaw chuck. I've got another 3-jaw chuck on the lathe now, a bigger one. So I'm going to use this plate. Maybe I will turn a pilot in here and use a locating ring to locate on this. I don't know exactly what I'm going to do yet, but I'm going to adapt this to the buck chuck. Yeah, maybe I'll make an intermediate plate, goes between them. I don't know. I'm going to lay these out on CAD and see how much room I've got to work with. So here's a model of the backing plate from the 3-jaw chuck. It has a pilot that pilots it in that chuck, and then 3 bolts to retain that from the rear, the 3 studs from the D14 mount, and the 7¼ taper that all those D1 mounts use. So basically the only modification that I have to make to this backing plate to work is to put in the 3/8 tapped holes, pattern of 4, which appear to be on a 3" by 3" rectangle or square. And then this would mount the 4-jaw buck chuck to this backing plate. And what I'm going to do is I'm going to use this bore, which is 2" 400 thousandths, to pilot an adapter piece. And the adapter piece, which I'm calling the pilot insert, is going to be made out of just basically a 1/2" thick plate. And I'm going to rough it out, put a hole in the center, and then this basically has a thousandths press fit on that 2.400 diameter, so I'll try to shoot for about 2.401. The ID, I believe, is a 2" hole, and the OD needs to be 3" 100 thousandths, plus a 1/2 thousandths or a 1/1000th for a press fit into the buck chuck. And then what I end up with as an adapter looks like this. So no modifications to the backing plate except for 4 tapped holes, an insert pressed in. After I rough it out, I will probably mount the backing plate, mount it, remount it a few times, make sure it repeats, and then turn that diameter so that it is perfectly concentric on the lathe. So do you remember these? These are the axle adapters for my son's Spitfire. He's putting in this third-party differential that has limited slip, and it's narrower than the original differential, so the spacers take up the distance in width. I'll take a look at them now. So as you can see, we had a little bit of a screw up. Thankfully this was not mine. I made it to print. But we figured out what happened. The scallops here, which are the bolt pattern that loads on top of the axle stub itself, he had the, let's call it the height correct. And the way he did this was he measured, outside the stud, inside the stud, took the average, and that's the center to center. Well, in this direction, he's exactly 1 bolt diameter too wide. So he just ended up probably, having several numbers written down on the page, and he used the outside to outside and drew that as the center to center. So these do not load onto the the axle studs. So he wanted me to just make them over. I said, well, weld them up. Just weld them up. Now that we got the lathe running, I can face these, face the OD. Not much to chuck on, but it'll work. And then once I get them back to their original surfaces, I'll just put in these 4 new, through holes and scallops on their new location, and it'll still be less work than making the whole thing from scratch. These scallops, once they move in, are probably going to break into this clearance bore, but that's not a big deal. As long as, the hardware and the stud don't interfere with the pilot on the mating, axle flange, he'll be good to go. He'll just have a little tiny cutout here and, in those 4 locations. So this will be a future project. So that's a setback, but you got to do what you got to do. Well, we had a little bit of wind last night, and look what happened. Blew one of the doors off of the building. Actually, it wasn't just the door, it was the door and the track that it rolls in. Ripped it right off, ripped the welds. Both of the little trolleys are still attached, but they're kind of beat up. Doors are 12 feet wide, 16 feet tall. I'd say they weigh about maybe 300 pounds. It's heavy enough where I don't know how I'm going to flip it over or get it back in place. It's made of 3-inch square tubing, about 1/8 inch wall welded into a frame, and then the PBR panels, 12-foot PBR panels, are attached to that. So technically this door was coming off anyway. The last 12 feet of the building, 12.5 feet, I was going to enclose on both sides. So far side and near side, I was going to get, those are called C's. I was going to get a C member, fasten it top to bottom, and then 2 girts. And then I was going to use the panels from this door to skin this 12.5 foot wall. And on this rear wall, I need another girt to go from here to that mounting tab. Then I need some more 12-foot panels to enclose that opening. And I need some 7-foot long panels to enclose this opening. So these buildings are made so that these lower level girts are high enough where you can put a 6'8" door anywhere, you know, in that sidewall and be under that lower girt. Then it's 5 feet to the next girt. So we have a 7-foot spacing from the floor to the first girt, 5 feet to the second girt, 5 feet to the eave. All these building components are stock items, but I don't know how if they make them just in long lengths and then chop them off to the length you need. Probably they roll them off of a flat sheet. So just another job that I did not anticipate having to do just yet, but I got to do something about this. Let's get the drone out and assess the carnage from up close. I want to take a look at those mounting points where the tabs ripped off. I'm going to record the audio here on a separate device so that I can narrate while I'm flying here. So let's get the drone off the ground.
Take off. The home point has been updated. Please check it on the map.
See how close I dare fly to the eave. You got some eddies and swirls coming off the building, so it's making it a little interesting to keep it steady. So this is just the sidewall, and that skirt board covering the track where the doors retract. There's the edge of the door. There's the door. There's where the skirt board has come off. Let's get in a little closer. The wind is making it real hard to hold steady. You can see that truss that they rigged up under there, which I don't know why they did that, because the building is engineered to hold snow loads, and so you got a 25-foot span in between the major uprights, and I hardly think that little truss wire is going to do anything. Well, what you just saw was me trying to get ready to the best of my ability for the remnants of Ian. You know, we're not going to get hit anywhere near as bad as the people in Florida or Charleston or anywhere in the coast, but they are predicting up to about 5 inches of rain and 40-mile-an-hour winds. And basically what that means is everything in here is going to get soaking wet, because the wind will just blow in, blow the rain. It'll be mist everywhere. So got the heater fan on the K&T to heat that up. Got a couple of 250 watt brooder lights on the Cincinnati grinder. I've got a little 500 watt Amazon space heater inside the granite table, because that tends to get pretty dewy. I sprayed down all the surfaces of the measuring arm. They're starting to develop some flash rust. Sprayed down the chuck on the lathe. I'm not going to spray down the joiner, but I did put a a light in it to warm up the cast iron. That'll help keep it dry. If I spray everything down, then that's going to transfer to any wood that I will be working. And the rest of it will just have to cope with what Mother Nature dishes out. Well, that's it for today. I hope you enjoyed it. Didn't have really any machining, but did get that buck chuck cleaned up a bit, and I have a path forward for making an adapter to have it work on the Aquaturn lathe. And, lastly, I pretty much had to button down the hatches for the upcoming rain and wind, the remnants of Ian that we were going to get. So that's all for this week. Join us again next week. Hope to have a little bit more in-depth content, either mounting up that buck chuck or getting some parts remaking my son's axle adapters. Lots to do. Just see what rises to the top of the pile first. So hope everybody has a safe time at home. Hope nobody's affected by this horrible weather. Our hearts go out to everybody in Florida and on the East Coast that were affected by Ian. So until next time, as always, stay safe.